Hello, welcome to lesson 2.8. So, in this lesson, we're going to talk about how do we use this equation to calculate the number of calories in food substances, right? And in general, we can apply this to other things like different metals and things like that. But since this is medical chemistry, we're going to focus mostly on food calories. So, something that you should have down is the definition of calories. So, let's read it first and see if it makes sense. So, calories is the amounts of heat required at a pressure of 1 atmosphere to raise the temperature of 1 gram of water 1 degree. So, this is kind of a weird definition because if you think about it, oftentimes when we see calories, we're measuring calories in food. So, what does this have to do with water being at 1 atmosphere in terms of the pressure, right? So basically, what this means is if I were to summarize this into common English, essentially, this means this is the amounts of energy we can get from something if we transfer all of the energy into water at sea level, right? So all this means is all of the energy in the food we're going to transfer into the water. So this is a basic calorimeter setup, right? So if you were to try to measure calories at home, it would look something like this. So essentially you would have your food where there's energy stored in here, and you would burn that food similar to what was mentioned in lesson 2.7. So when you burn this food, let me change the color a little bit. All of the heat energy that I'm drawing in red is going to go into the water, right? So all of the heat energy, I'm going to label E for energy, is going to go into the water. And then all of the energy in the water is then going to be transferred into a thermometer. So this stick thing, let's call that my thermometer. So now we know, okay, this is what it means by water. We're not measuring just the energy from water every single time, but we're going to use water to measure the energy of different things. So if I want to measure the energy of a cashew, I'm going to burn the cashew and transfer all of that energy into the cashew. If I want to find the energy in salad or a pencil, I'm going to burn those things and then transfer all of the energy into the water, right? So you might wonder at this point, why water? Well, looking at our equation, this will help us figure that part out, right? And the reason why we use water is because using this equation, we know the specific heat of water is 1 calorie per gram per degree Celsius. So, as scientists, if we use and transfer all of the energy into water every single time, it just makes our math so much easier to multiply by 1 when we're calculating calories, right? And that's why we always transfer all of the energy into water. It's just easier to do math that way. So, therefore, because we're transferring all of the energy into water, our equation is as follows. So to find the number of calories or Q in the in a substance, whether that be a cashew or a salad or different metals or even a pencil, right? Here's the information we need. So we would need the mass or M in grams, that's our units, of the water that we used, right? So here, if I'm transferring all the energy into the water, if I use 50 milliliters of water, that equates to 50 grams of water, right? So 1 milliliter of water is the same as 1 gram of water, right? So M in our equation is always the mass of water, right? So then we multiply that by the specific heat of water because, again, we've already transferred all the energy of the water. So we only need to measure things in the water. For your specific heats, the specific heats, since we're using water every single time to make our math super easy, our specific heat is always going to be 1 calorie per gram times degrees Celsius, right? So something that would be helpful would be to write this information down in your notebook as well, right? So know what the equation symbol represents in terms of the units you're looking for and what they actually mean, right? And finally, if we want to measure the heat or energy in the food item, once we've transferred all of the energy into the water, right, we know how much that energy is changing based off of the specific heat number. And we need to know how much energy difference is created by reading the thermometer. So I need to know the starting temperature of the water before I burn the food. We call that the initial temperature. And we also need to know the final temperature of the food item. All right, so after everything is burned, what is the final temperature reading of the water? Right, so these are all the parts of the equation. And in the next part of the video, I'm going to talk about how we use each part of the equation if we were to actually do a lab on this. All right, so in this section of the video, we're going to talk about how do we use this equation to figure out how many calories is in a cashew, right? So similar setup. So here's our calorimeter again. And remember that in order for me to calculate the calories of something, I need to know the mass of the water that I'm using, the specific heat of water, and the change in the temperature of the water. And again, we need to know things about the water, not about the food itself, because we're going to transfer all of this heat energy into the water itself, right? So no matter what I'm burning in terms of the food item, I'm always going to change and transfer all of that energy into the water because it's just easier to calculate mathematically since we know the specific heat of water, right? But we might not know the specific heats of the food that we're using because there's just so many ingredients in it. All right. So when I first start out in this lab, I need to figure out how much water I have to start with. So in here, in this problem in particular, let's say we added 50 milliliters of water. So therefore, my M is going to be 50 grams. So M is 50. And then later on, I'm going to plug that into the equation. All right. So again, the grams is the amount of water that I'm using. C, what is that going to be? Well, C is our specific heat, and it will always be the specific heat of water because, again, we're going to transfer all of that heat energy into the water, right? So the specific heat of water is always 1 calorie per gram per degree Celsius. So it's always going to be 1. So no matter what, when we're working with this, a key note is that specific heat will always be 1. Well, what is our change in temperature? Well, when we first start out, before you burn the food, so before this part happens, you would take the initial or the starting temperature of the water. And in general, it'll usually be around 20 degrees because that is room temperature or Celsius or room temperature, right? So our initial temperature of water is going to be 20 degrees Celsius, right? And let's say we burn the food item, it starts to burn. Now the fire is lit, it's burning, 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 and then we have a new temperature, right? So our final temperature, I will usually give this to you in a problem, and let's say it goes up by 33.2 degrees Celsius, right? So our final temperature is going to be 33.2 zero point 0.2 degrees Celsius, right? So, in order to find the amount of calories that was released, we need to know the change in this temperature. So, to find the change in anything, we are just subtracting in this case. So, you would take 33.2 minus 20 degrees, which will give you 13.2 degrees Celsius. So if you subtract those two numbers, you get 13.2 degrees Celsius. So now I have all the components or variables in order for me to calculate how many calories is in this particular cashew. All right, so in my calculator, I'm going to type in 50 because that was the mass of the water times 1 because that is always the specific heat of the water times 13.2 because that is the temperature change in the water before we burn the cashew and then after we burn the cashew. So type that into your calculator and you should get 660 calories. So keep in mind that when you write in the unit calories, you should always write in lowercase c calories because this is different from your nutrition facts label, right? So 660 lowercase c calories is essentially 1 capital C calorie. So keep in mind that 1,000 lowercase c calorie is 1 capital C calorie. And you might be wondering, wait, what does that even mean? Why is there a difference between lowercase c calories and capital C calories? Well, if you could, go ahead and find a snack right now and look at the nutrition facts label, right? So if you look at the nutrition facts label for a cashew, I just Googled search this real quick. Notice that this is in capital C. And if you look at every single snack that you find, all of the nutrition facts labels is in capital C. So this 155 calories is not in lowercase c. It essentially means that you don't have 155 calories here. What we have in actuality is 1,000 times greater than this. So this is actually 155,000 calories, right? So normally in the metric system and in other countries, if you remember the metric system, we have K for kilocalories, right? And oftentimes, if you check the nutrition facts in almost every other country that's where the food is not made in the US, you'll see that their labels will say K calories or K joules or KJ, which is another unit of energy, rather than just capital C calories. And the reason is because mainly we don't have the metric system. It's not as common here in the United States. So to differentiate it, we have capital C calories versus lowercase c calories instead of the kilocalories, right? It's super confusing. But essentially, what that means is when you consume 1 capital C calorie, you're actually consuming 1,000 calories, right? And the reason why in the US we use capital C and lowercase c to differentiate this is because we don't often use kilo, hecto, and things like that, right? Or you can say that this is a marketing ploy to make us feel less bad about eating calories, right? So in lesson 2.8b, if this was confusing, I'm going to go over a couple more practice problems with you to help you out.